Okay, so we got to match something from this column with this column. So the negative is on the outside. We're square rooting 16 to get 4, and then we're putting the negative. So this is negative 4. So this is E. For number 2, the negative is in the inside of the square root, and you cannot square root a negative number, so this is not a real number. So that's F. Number 3, you can cube root a negative number. The cube root of negative 27 is negative 3, so that's D. And that's because the index is odd. Whenever you have an odd index, the negative just pops right out, and then you're really just cube rooting the 27. Okay, and again, this is an odd index, so the negative is going to pop right out, and we're fifth rooting 32, and we get 2. So this is negative 2. That's B. Here we're fourth rooting 16, 2 to the fourth power is 16, so this is 2. That's a C. And finally, this negative's on the outside, so first we're cube rooting 64 to get 4, and then we're popping on the negative to get negative 4. So that's E. Okay, for number 13, we're square rooting 81 to get 9, then we're putting the negative, so this is negative 9. For number 15, we're cube rooting the 16, so you can use a calculator for that, but the cube root of 216 is 8. Oops, except it's not 8, it's 6. That's 6. All right, because this is an odd, the negative just comes right out. And then so this is equal to a negative, and then we're cube rooting the 64 to get 4. Here we're gonna cube root 512, that's 8, and then we'll tack on the negative. Okay, you can just use a calculator, but the fourth root of 1296 is 6. That's because 6 to the fourth power is 1296. So this is just 6. Now we're going to fourth root the 16 to get 2, but then we got to tack on that negative. So it's negative 2. All right, this is an even index, and we have a negative in here, so we can't do this, so this is not a real number. Okay, the sixth root of 729, make sure you know how to do that on your calculator. That's simply 3. This is an even index with a negative in it. We can't do that, so this is not a real number. Now we're going to square root both the numerator and the denominator. We square root 64 and we get 8, square root 81 and we get 9. It might be easier to think of this. There's a couple of ways to do this. One way is to think of 0.49 as 49 over 100. That's 0.49. And if you square root that, you get 7 over 10. Which, if you want to write as a decimal, is 0.7. Otherwise, you can just use a calculator to do the square root of 0.49. Okay, we're going to cube root 64 and get 4. Cube root 27 and get 3. Now the negative is on the outside, so our answer is negative. And the sixth root of 1 is 1, and the sixth root of 64 is 2. Okay, the cube root of 0.001 is simply 0.1. And that's it. Okay, the square root is like unsquaring. So this is a 12 squared, so if we unsquare a square, we just get that number out. So it's just 12. This is going to be a positive 10, and the reason why it's not negative 10 is because when you square this, you get the square gets rid of the negative to make it a positive 100. So it's like this. And then when you square root that, you get 10. But really, all you had to realize that this was going to be positive, and we unsquared the 10, so we just got 10. So this is even. This is going to become positive because we're taking it to an even exponent. Then we take it back down. So this is just going to be 2. When you take something to an odd exponent, it becomes negative. So this will become a negative, whatever 9 to the 5th is. And then when we take it back down, it's still going to be negative. So this will be negative 9. Okay. Ignoring the negative for the time being, this will become a positive 5 because we're taking it to an even power and then back down. That'll be a positive 5, but then we tack on the negative, so this will be negative 5. This will be x. Actually, this is the absolute value of x because we don't know if x is positive or negative. So if x were, pretend x were negative 1, then you'd have the square root of negative 1 squared, which is the square root of positive 1, which is 1. But that's 1 is equal to the opposite of what x was. So this would have been equal to negative x. And if x were positive 1, then you would have the square root of positive 1 squared, which is the square root of 1, which is 1. And that's equal to x, what we started out with. So because we don't know whether x is positive or negative, all we know is that the square root of x squared is the absolute value of x. Okay. This is going to be the absolute value of z for the same reason that that's the absolute value of x. This is going to be x, not the absolute value of x, because, and the rule to know is that if you take an odd exponent to an odd root, you get this without an absolute value. And the reason why is, let's pretend x were equal to negative 1. This would be the cube root of negative 1 cubed, which is the cube root of negative 1, which is negative 1, which is equal to x. If x were equal to positive 1, you'd have the cube root of 1 cubed, which is the cube root of 1, which is 1, and that's equal to x. In either case, it's equal to x. You don't need the absolute values like you do in the other ones. So this is going to be x to the 5th power because when we take this out, we're dividing the 15 by the 3. And we don't need the absolute values because this is an odd exponent that it ends up with. All right. This is going to be the absolute value of x to the 5th power. I guess the easy way to remember is that if you have an even exponent inside of the radical, and when you take it out, it becomes an odd exponent, then you need the absolute values. And that's it. If it was an odd and it comes out, you don't need that.